last video, my iPad was running out of storage, I guess, but hopefully this one works. So I'll just pick up where I left off at the end. We'll try to start on this first one here, basically. So take a look at it again. You can pause the video, see what you can do. This one you might be able to figure out if you've been kind of picking up on these the last few days and even this week before spring break. But see what you can do with these three over here. Maybe change a couple things. See if you can get this to be sine squared. So again, if you want to pause it real quick, go ahead, and then I'll try to show how to do it here. So what you're going to want to do again is look at a few of these tips up here, but basically start with the more complicated side. Try to change some things here to try to get it to look like this side. But also look at what is over here. It's sine squared. So if there's a sine here, I'm probably not going to need to get rid of that. I'll probably leave that. But I need to try to get these to somehow just turn into another sine. So that sine times this will be sine squared. So again, there's not always a way that's obvious to start. Just kind of have to sometimes just pick something and just go with it, see what happens. But on this one, the tangent squared, or the tangent, I mean, you can change into 1 over the cotangent if you chose to. But if you look over here, there's no cotangent over here, so it probably won't help to change it into cotangent. But the tangent could also be changed into sine over the cosine. So that's what's going to be useful here. So if I change the tangent of x into the sine over the cosine, so just keep the sine of x here from the first factor, change this into sine of x over cosine of x. And then I could choose to change the cosine into something if I wanted to, but if I notice there's a cosine on the bottom of this, if I leave that cosine of x right there, I can probably see what's going to happen. So again, I'm trying to show that this equals sine of x squared. Now luckily this cosine over 1 times sine over cosine, the cosines would just reduce out of there. So then you just have sine times sine over 1 basically, so you have sine of x squared, which proves that it equals the sine of x squared. So in the answer, there's no real answer here. I mean, you could put a box around this if you want, say that's my answer, but really we knew it was going to equal sine squared of x because the problem told us it has to. Our solution is basically our proof of it here, our steps that we showed here. So that proves that this will always equal sine squared of x. So that's the first one. The second one here, again, if you want to pause it, try this, see what you can do with it, see if you can get this to equal sine squared, go ahead. Otherwise, I'll kind of go through a couple strategies you can use on this one. So, two ways that come to mind right away. One is using that last thing we studied yesterday, or on the video from yesterday. So if you remember at the end of the video from yesterday, the last problem I had you try to do was this one here, where we took this over sine squared and we broke it into 2 fractions over sine squared. So that's always a good strategy. If you have 2 terms over 1 term, you want to break it into 2 fractions. Sometimes that can help you. That's one way to do this one. It's not the only way to start this one, but I'll show that way first, and then I'll come back and show a second way on this one too. So if you break this into 2 numbers over the secant squared, this is probably the fastest way to do this one. You'll get secant squared of theta over secant squared of theta, and then it'd be minus just the 1 over the secant squared of theta. So again, I'm just taking this fraction, breaking it down into 2 fractions, maybe imagining that I had 2 fractions before and I subtracted them and got that. What would those 2 fractions look like? So you can see these 2 fractions would subtract to that one. Now this is pretty easy. Anything over itself is always just equal to 1. So that's 1 minus. And then 1 over secant squared. And then 1 over secant equals the cosine. So 1 over secant squared will be the cosine squared. So this will just be equal to cosine squared of theta. And then this one you might have recognized already or memorized already. 1 minus the cosine squared from this Pythagorean identity equals the sine squared. So that's what we're trying to get it to equal, so that's our proof of it there. So that would be verifying that identity. We verified that this always equals the sine of theta squared. Now that's just one way to do that one. You may have done it a different way. So on a different day, if I looked at that one, I might have started a different way too. So I'll show a separate way you could have done that one. You might have also looked at the top and noticed secant squared minus 1. And that might have made you think of these identities here, like the tangent squared plus 1 equals the secant squared. So now this has secant squared minus 1. So that's not really exactly what this identity says, but it's pretty easy to just take away 1 on both sides. if you want to figure out what is secant squared of theta minus 1 equal, and that equals the tangent of theta squared. So it's kind of like a new identity you added to your list there. You can use the top one if that's useful. If that's more like what you have in your problem, you can use this one. So I could change the secant squared minus 1 into tangent squared as another option. So that would be tangent squared of theta on the top over secant squared of theta. And remember, I'm trying to get that to equal sine squared of theta. So this is where that step up there, I think it's up here, it's I think number 4. It says if nothing else helps, try to convert all things to sine and cosine. You could try to do that. Just change tangent into sine over cosine and change secant into 1 over the cosine. So tangent is sine over cosine, so tangent squared will be sine squared over cosine squared. So that's just the tangent would equal that. And then the secant squared is 1 over the cosine squared. Now this is getting a little complicated, but you might be able to see how this is going to simplify to sine squared. Because if you have one fraction divided by another, you'll multiply by the reciprocal of the second one. So it's this divided by this, or this multiplied by the reciprocal of the bottom. So if you just kind of imagine flipping this upside down to multiply by cosine squared over 1, you'll see the cosine squareds would cancel out and you'd get the sine squared, which is what we're hoping to get, is the sine squared of theta. So that's a second way you can prove that the left side equals the right side on that one. So this one's probably a little more complicated. This one, simple, but you just had to recognize that you could have broken that into 2 fractions. So again, not always your first thought works, and sometimes your first thought might be different than somebody else's. They might both work. So just try something. If you get stuck, maybe start over again. If you try it 2 times, it's still not working, you're getting frustrated, maybe just skip to the next one and try to come back to it, or look when I put up the solutions. But again, trying to get too frustrated on these, just try something. It's not always going to work as nicely as it does when I do it, because I kind of know what's going to work. I've done these before. So don't expect your first try to always look as nice and simple as mine. Sometimes you'll try the first thing, it works out nicely. Sometimes your first thought won't work out so nicely. Just try to keep practicing them. Again, don't expect yourself to get them all perfect the first time through. So I'll just do a couple more of these and then just have you try a few of these today. So C, this one you could do a couple different ways. Typically, from what I've seen doing these, is when you have 2 terms that are subtracted or added on one side, and the other side there's just one term, they're just multiplied together. It's usually important to take these 2 and try to subtract them, like with a common denominator, and get them to look like this. It's pretty hard to break this up into 2 terms, but it's easier to take 2 terms and subtract them. So to do that, you're probably just going to take one or both of these and turn them into a fraction. So secant can always be turned into 1 over the cosine. So the secant of t is the same as 1 over the cosine of t. Then if you're subtracting cosine of t, you could kind of put that over a 1. So I'm just starting with the right side, see if I can get this right side to look like the left side. So to get a common denominator, I'm going to need to multiply this one at least to make them both have cosine as the denominator. So first fraction, I'll just keep it the same. The second fraction, going to need to change it so that the denominator is cosine. So I'll multiply by cosine of t, multiply by cosine of t. So I'll get cosine of t squared, or just cosine squared, over cosine of t. And in the last video I mentioned, if you don't want to put the t's every time, you can just take off the t's until you get to the end. That's fine. I might start doing that on some of the examples. So if you see me stop writing the variable, don't get confused. It's just kind of quicker that way. So if I'm going to do this one, subtract the 2 on the top, get 1 minus cosine squared over the cosine. So again, I'll just write it without the t's just to save a little time. So that's what you get if you subtract those, and then you'd probably recognize by now that 1 minus the cosine squared. We've seen similar ones to that a lot. That's where you can use this Pythagorean identity. So 1 minus the cosine squared equals the sine squared. So I can just change the top into the sine squared over the cosine. Now this is a step where probably, I don't know, most people I would think would do this one way. Some people might do it a different way. So what I would probably do is just keep this as it is and go to the other side and see if I can get the other side to also look like this. That's probably gonna be the easiest way to prove this. Some people could get creative and kind of break this into two fractions and get it to be, one of them be sine, one of them be tangent. So it's up to you. If you want to keep going with this, see if you can like think of this as two fractions that multiply, so you can think of like two things that would multiply to this. And then see if you can get one of them to be sine and one of them to be tangent. That's one way to do it. If you get down to something like this, it's pretty simplified. You could just stop there, pause there, and go over to the other side and see if you can change that into sine squared over cosine, because that would also prove that these both sides are equal. So that's what I'll do first, is try to take this and get it to look like this. So if I see the sine on the top and I see a sine on top here, probably leave the sine, but the tangent could be changed into sine over cosine. So I'll just keep the sine of t, change the tangent into sine over cosine. And then if I multiply those together, it's pretty easy to see I get sine squared over cosine. And that's exactly what I had on this side. So right there, that kind of proves both sides are always going to be the same. So if you want to just do it that way, go ahead. If you wanted to, and take this and change this into sine over 1 times the sine over the cosine, because that's what sine squared over cosine would break into, then you could say that's equal to sine times the tangent. So sine t times tangent of t, which is the same thing you started with up here. So there's two ways to kind of prove that once you get down to that step right here. You could stop there, switch over to the other side and get it to be the same, or you could just keep going from there, see if you can get it to look like what you started with there. So again, look back, watch that one again if you need to, or maybe just try it again on your own and see if you can get either down to here on both sides or get it all the way to there. So the next one looks pretty complicated, but it's basically just, if you can add those first two fractions together, it won't be very difficult after you get that done. So again, if you want to pause this, try to just add these two fractions together first, see if you can simplify it down to this. If not, I'll just start working on it here. So to get these to have the same denominator, there's no simple denominator you can use with these two. You're just going to need to multiply them together. So the denominator of both is going to be 1 plus cosine times 1 minus cosine. So this is going to be pretty complicated the first couple steps, but it will simplify quite a bit. So to get this to be 1 plus cosine, I'm going to need to multiply by 1 minus cosine on the top and the bottom. So you don't even need to write all that. If you want to just skip to this, be 1 minus cosine. Then I'm going to multiply this by 1 plus cosine and 1 plus cosine, so the top's going to be 1 plus cosine. So now if you add those two together along the top, the minus cosine plus the cosine is going to cancel out, but the 1 plus the 1 will just add up to 2. So it'll be 2 on the top, and then the bottom for right now says 1 plus cosine and 1 minus cosine. And then this might be a good step to take a break and look at what we're trying to get this to equal. So we're trying to get this to equal this. Now one good sign is we have a 2, so that should look pretty good so far. We're just trying to get this bottom to somehow turn into cosecant squared. So sometimes you distribute, sometimes you don't. On this one, there's nothing else to do other than probably distribute these two. So again, just like FOILing or distributing two binomials you learned back in Math 2, just multiply this by this, you get a 1. So I'll put the 2 on the top from the numerator, but 1 times 1 on the bottom will be 1. 1 times negative cosine will be negative cosine. Cosine times 1 will be positive cosine. And then cosine times cosine is cosine squared, but positive times a negative will be negative cosine squared. So this might remind you of that first problem we did at the beginning of yesterday's video where we distributed 1 plus sine and 1 minus sine. Distributed to something like this. These cancel out, negative cosine, positive cosine. So now you have 2 on the top, 1 minus cosine squared on the bottom. And then you might start to see how you're going to get that to be 2 cosecant squared of x. So the denominator 1 minus cosine squared, we've used this one a lot the last couple of videos. 1 minus cosine squared equals sine squared. So this is basically equal to 2 over the sine of x squared. Now you're pretty much there because 2 over the sine is equal to 2 cosecant. But you could kind of show this a couple different ways. You could take this and change cosecant into 1 over sine squared and get it to look like that. Or you could think of this as like 2 times 1 over the sine squared of x, because that's what you could break this into. And then 1 over sine squared is the cosecant squared. So this is 2 cosecant of x squared. So again, we knew that answer all along. Is just the proof is basically the work here. This is what you're trying to show, how you can prove that this equals 2 cosecant squared. So just do one more on here. If you think you got the hang of this, I'll show you the homework in a second, or you can just fast forward to it. But this one's E, I'll just do one more like this. This is going to be pretty similar to how we did C above. So you got two terms to add together, just like we had these two terms that needed to be subtracted. So I'm going to end up adding these together, see if I can get it to equal to that. So if you want to pause it, try it yourself, go ahead. If you're kind of getting the hang of this, you want to just skip ahead to the homework, you can fast forward. I'll show the homework in probably a couple minutes. So this one here, I'm going to need to add these together. Now there's actually two good ways to do this one. Sometimes people would turn this into 1 over cotangent and try to add them. That works. I think it's even easier on this one if I remember. If I change tangent into sine over cosine, and then I change cotangent into cosine over the sine. So again, if you're not sure yet where I got those from this step right here, or this section here, the quotient identities, these two. So I just use those. Actually, now that I think about it, I don't remember if this is the easier way or not. I can't remember. One of them's easier than the other. It might be easier to change this into 1 over cotangent and add them together if you want to try that. But I'll just keep working with this. So if I'm going to get a common denominator on these, I need to use these two denominators. So my common denominator is going to be cosine times sine. And then this denominator is going to be cosine times sine also. So you're going to need to multiply this one by cosine of x, or cosine, multiply the top by cosine. So that's cosine times cosine, which is cosine squared. This one I'm going to need to multiply by sine on the bottom and sine on the top. So that's going to be sine squared. So yeah, I'm pretty sure this is the easier way to do it out of the two ways. Now when you get to here, you can just add the numerators together. You might even already be thinking ahead what that's going to add to using that identity, but if you haven't recognized it yet, just write sine squared plus cosine squared on the top. On the bottom, it's going to be sine times cosine, or cosine times sine, however you want to write it. Now the top, and hopefully you recognize that. If not, just the more you do these, the more you'll recognize the common ones. But sine squared plus the cosine squared always equals 1. So we can just change the top of this fraction into a 1. So this really equals 1 over sine times cosine. Now this is where you might look back at what your goal is. Your goal is to get it to look like this right here. So we have 1 over sine over cosine. We're trying to get secant, cosecant. It looks like you might be able to see what's going to happen here, because 1 over sine is cosecant, 1 over cosine is secant. So you could just basically say this equals that, because it does. If you want to kind of show it a little bit better, you could break this into two fractions that multiply together. So 1 over sine times 1 over cosine, because those would multiply together to this. And then 1 over sine, that equals the cosecant. So this would be cosecant x, and 1 over cosine is the secant of x. And cosecant times secant is the same as secant times cosecant. So that's how you can prove both sides of this are equal to each other. So again, these can be fun if you're good at them, if you get kind of the hang of it, or if you just get lucky and your first instinct works. They can also be really frustrating if your first option doesn't work and you work it through for 2 minutes and you get nowhere, and you start over again and work for 3 or 4 more minutes, you still get nowhere. They can be frustrating, but again, it's kind of a challenge. Sometimes it's a good, just satisfying challenge when you actually complete it and you figure out a way to prove it. So just take your time on these. Don't get too, upset if you don't get through them. If you have to skip a few, that's fine too. Just spend maybe 30 minutes or so trying to do as many of these as you can on the homework. If you're quick, you might even be able to finish all of them in 10 minutes or so. So again, don't spend 2 hours just frustrating the heck out of yourself trying to get these done. Just do what you can. Try at least once or twice each one. If it's not working, just skip ahead and maybe check the solution later. So the homework is to try a few of these. So I'll just leave this up for a second, and then again, if you need to pause it and write them down, go ahead. So you'll try to somehow make this equal 1. Should be kind of a simple one there to start out with. This variables, like they use B, there's like beta. It's like kind of the B in the Greek alphabet. This is another variable. So you'll see some strange variables in there. I think this is, I think this might be sigma. No, I think this is like phi or something like that. So you'll see different variables in here, but you don't even need to write the variables if you don't want to. Just try to get the cotangent squared times the secant squared minus 1 to equal 1. So try those, and then there's a couple more down here. So these down here, this one right here says it's very easy, but it's actually impossible. The way I wrote it, I kind of messed it up. So for this to be easy, this would need to be 1 over the cosine right here. So instead of cosecant, this should have been cosine. So again, now that I fixed it, it is really easy, so don't spend more than 5 seconds trying to do that one. It should be really easy. But the rest of these will be similar to the ones I was working through earlier. So on the back, a few more problems. If you need to rewind and copy those down again. So try these. So there's about 10 or 11 of those to practice. And then there's a little bit of factoring practice down here just to keep the hang of how to factor things. So I'll put up those answers later. Just try your best for now. Again, when we can get together live on the Zoom, just if there's one you got really frustrated on, you just want to have me, like, you can kind of show me what you did. I can kind of help you figure out how to fix it from where you're at. We can do that. So tomorrow's lesson, I'll just show you maybe 2 or 3 more examples and give you just some time to practice them. So it should be a short one tomorrow, and just keep practicing these. And then that's all we're going to do with these. Hopefully you're kind of getting the hang of some of them. Hopefully by tomorrow you're able to do a few on your own. So again, just stick with it, but don't frustrate yourself too much on any one problem. If you get stuck on a few, that's no big deal. Like looking at 9 on here, 9 looks kind of tricky. So try your best on 9. If you get a little confused, don't worry too much about it. So again, just let me know which ones you got questions on. Don't hesitate to email me or just show up on the Zoom video, Zoom meeting, see if you can ask some questions there. Or I don't know if you have ways to communicate with each other, see if you can help each other out too. So again, I'll check back with you on the next video or maybe in a Zoom in the meantime.